And now let's look at how the model itself fine-tunes these weights to come up with a final set of values. So we have one node for each input predictor. So you'll have a value coming in each observation, and the value for node 1 and input value for node 1, input value for node 2 are used to update the functions for these nodes. And then an error will be computed at the end, and the error will be used to propagate back, and in the backward pass we update all these weights. Yes, let's look at a simple example. Okay, let's take the first observation. So remember, in the simple example we have 6 observations. So here is the data set, and it has 2 predictor variables, fat score and salt score, and then whether the cheese is acceptable or not is the target. So the very first observation has a value of 0.2 for fat score and 0.9 for salt score, and the y value is 1 for target. Okay, so the fat input is 0.2 and 0.9. Okay, so here is fat equal to 0.2, salt equal to 0.9 coming in. Now you take the way in which node 3 will be calculated. Okay, so we have to calculate using the input values. We calculate the output value for the nodes. So again, there are 2 inputs coming in. Okay, 0.2 and 0.9, and they have weights of 0.05 and 0.01. So multiply the input value with the weight, okay, and then add the bias to it. So remember, the bias was 0.3, and then you multiply the weights, and what you get is an S function. And then you have to take the S function and convert it into an output value. So this is the formula. So this is the S function is bias plus each input predictor value times the weight, add them all up, so you get the S value. Okay. And then you take the S value, and the output is G of S, and that is 1 over 1 plus e to the power of minus Sj. So for node 3, this will look like this. So node 3, the bias is minus 0.3, so multiply x sub 1 of 0.2 with its weight, x sub 2 of 0.9 with its weight, s sub 3 is this, and then you convert that s sub 3 into the output value of 0.43. So you do those computations for each of the 3 nodes, and you get the 3 output values going out of 3, going out of 4, and going out of 5. Now these output values will now serve as the input value for the next layer. Now at the output side, okay, like here, we take the inputs coming in from 3, 4, and 5, and then the bias, and we do the computations exactly like before. So for S sub 6, yeah, so theta sub 6 times the output coming out of 3 times its weight, output coming out of 4 times its weight, output coming out of 5 times its weight. And add them up, and you get the S function value, S sub 6, and G of S sub 6 is you use the same formula and you compute that. And in a similar fashion, you compute the output for 7. So now we have output for 6 and output for 7. And here is how the entire calculations look like, and this is for the very first observation. We still have 5 more observations to go. Okay, so now after we complete the first observation, so we have the output value, then we can compute what is called an error. Resemble a linear regression, like this will be like the intercept beta sub 0 plus this will be like the slope times the x value, and so on. Okay, there is an appearance of similarity, but the methods are fundamentally different.